today I'm going to talk about the dot product and the cross product. So the dot product and the cross products are going to be extremely important concepts coming up in calculus 3. So what is the dot product? So pretty much the dot product is used to find angles between vectors. That's one of its main purpose. The resulting operation of a dot product is a scalar. So how will this work? So I'm gonna give this example. So let's say I have this vector u is 5, 10, -5, and then v is -1, 2, 4. I want to find the angle between them, just based on those two vectors. So what I can do, there's two formulas. There's a couple formulas to find the dot product. So this is how it's noted. So u dot v is equal to the dot product. So that's one way. And then another way is the magnitude of u is equal to, multiplied to the magnitude of v multiplied by cosine theta. So we're going to use that to find the dot product. So if we see this formula, we want to find the angle, right? So what is the angle? So we can set cosine by itself. So we can have u dotted with v all over u times v, the magnitudes cosine theta. Okay, so let's first start off with the magnitudes. What the magnitude of u is just like, again, the Pythagorean theorem. So u is 25. I'm just squaring it right away. 100 plus 25. That's gonna give me a magnitude of 150, square root of 150. Okay, and then for v, we can do the same thing. It's going to be 1 plus 4 plus 16. And then that's, when we've simplified, that's going to be 21, square root of 21. Okay, so that's the magnitudes. So if we multiply them, so u times v, we're going to have 21 times 150. And then that's going to give us, if I multiply that, 21 times 150, it's going to give me 3,150. So 3,150. Okay, and then that's this part. Okay, so now what about this part? U dotted with v. The way you do it is you're going to multiply each component at a time and then add them together. So what I mean is, so you're going to take this 5, the x, then take the x in here and multiply them. So 5 times -1, that's -5. Then plus, take the y component, 10 times 2, that's 20. And then the other one, -5 times 4, that's -20. So plus 20, that's going to be a -20. Okay, so now what you do, this goes away, and then this is going to be -5. And then that's the resulting. And we already found out, oops, sorry, that's the square root. And we already found out what the denominator is, and we know what's the numerator. So the dot product, so not that this is the dot product, but the actual value of this whole thing is -5 square root of 3150. Remember, we still have that cosine and we want to find the angle. So what we do, we take the arc cosine. So take the arc cosine of -5 square root of 3150. theta, and that's going to give you an angle of, I have to change my calculator into degrees, so it's just easier to read. Okay, so that's going to give us an angle of 95 degrees. 95.1 degrees. So that's the angle between those two vectors. Okay. So that's example 1 with the dot product. Another example of the dot product that's very important is its projections of the dot product. So what do I mean by that? So for example, you have let's make up another vector. Let's make it just two-dimensional. We can do maybe 5 and 2. That's equal to u, and then v, we can set it. We can say that's we can say. Sorry, I'm thinking what angle we should use. So it's a good example. Actually, yeah, I do have a good one. So u, let's make u. Sorry. Okay, so let's make u 3, 0, and then let's make v 3, 4. Okay, so we can sketch it. So u is going to be 3, 0. It's going to be 3, so it's going to be like right here. And then v is going to be plus 3, sorry, plus 4. And then like 3 is going to be here, so like about here. Okay, so another property of vectors, it helps us determine how much is a certain vector projecting on the other. So like for example, a good way to think about it is if I have a flashlight and it's flashing right straight down, and if I take this and put it and flash it down to here, how much will this cover? So it'll probably cover about here. The shadow will cover about right here. So if I do it in a different color, probably right here. We want to find the actual scalar. We want to find the actual projection of this vector. So give me 1 second. Okay. So now that we have, now that we know what to do, we can find the actual scalar of when v is projected onto u. So this is v. This is u. Okay. So to find this, what we want to use this formula. We want to use the projection of vu is equal to the magnitude of u cosine theta v over the magnitude. So that's pretty much a unit vector. This thing is a unit vector. And then what we want to do, we kind of just want to plug everything in. And there's another thing that we want to actually use, and it's actually that's going to give us a certain vector, the vector like the actual direction, but we want to find the actual scalar, so the actual value magnitude of the component of u in the direction of v. So this is what I mean. So this is the other one. So scalar v u is equal to magnitude of u cosine theta. Or that can also be written as u dotted with v all over the magnitude of v. So if you can see right here, this is actually the scalar because these are two the same thing. So you need the scalar times this vector. So this is a scalar being multiplied to this unit vector. Okay, so let's find the scalar first, because if we find the scalar, we can just plug this in here and then find the actual projection. So let's we don't know the angle. We don't know the angle, so we have to use this. We have to use this because we don't know the angle. We cannot use cosine, and this is why this is like writing it this way is useful, because we're not always going to have the angle. So let's dot it first. So u dotted with 3, 4, and then if we dot it, that's going to be 9. 0 times 4 is just 9. So it's just 0, so it's just going to be 9. And then right here, this is the magnitude of v, correct? So the magnitude of v is going to be 9 plus 16. It's going to be 25. Square root of 25 is 5. Okay. So we have a scalar of v projected onto u. So it will be 9 over 5. That's the scale. Okay, so now we can use that number. Now we can use that number and plug into the actual projection. So projection of v onto u is equal to, we already found this because this is the same thing as this one. So it's 9 over 5 times, this is a unit vector, because you say this is a vector divided by its magnitude, so it makes it a unit vector. So what's v? We don't know what v is. V is 3, 4, and then what's the unit? What's the magnitude? Well, we already calculated that. It's 5. So 5 divided by 5. And now what we can do, we can just simplify it and find the actual projection. So this is going to be 25, 25, and then this is going to be 27, then this is going to be 36 and 25. So that's the actual projection of v onto u. And then this is the scalar. This is where it's going to be. Okay, so again, we found the scalar, because we need it for this, using this, and then we substitute into here, and then we already know what this was, and then we just substitute this magnitude into here, and then we find the projection, which is this, and then this is the scalar. Okay, so that's example 2. So now those are like the basics of that dot product. So now number 3, it's about the cross product. The cross product, it's a little different to compute. It's not straightforward as the others, as the dot product. So I'm gonna make this example. Let's say I have a point that's 5, 3, 9. Then I have another point that's 5, 7, 8. Sorry, this is point. Let's call this point Q. Let's call this point R. I'm gonna have 3 points because I'm gonna make 2 angles. 2 vectors, and you're gonna see why. So -1, -1, 3, and 2. Okay, so because these are 3 dots, we can agree. We can agree that these dots, it's gonna be, is gonna create some type of triangle like this. Correct. We can kind of quickly sketch it to see how maybe that's gonna look. So P, where will P be? So 5, 3, 9. So this is P. So about like right here. Okay, so where is Q? So 5, 7, and then 8. So it's a little more, it's a little down. So Q. And then where is R? So R is -1, 3, 2. So it's gonna be like, it's kind of gonna look like kind of like this. It's kind of like in a slight angle. So what we want to do, we want to create a unit vector. We want to create a vector that's, we see how Q is in the middle. So we want to make a PQ vector, PQ, and then QR. And remember how we make vectors, we just do terminal minus initials, the PQ. So it's it. Let's go from P to Q, Q to R. So P to Q, so terminal is the Q, so 5 minus 5, and then 7 minus 3, and then 9 minus 8. Okay, and then Q to R, we can do, so this is the terminal, so -1 to 5, minus 5, and then 3 minus 7, and then 2 minus 8. And then if we simplify them, we're going to have 0, 4, 1. Then we'll have -6, -4, -6. So those are our 2 vectors. Okay, so now we can talk about the cross product. So what is the cross product? The cross product is pretty much, you're pretty much creating a whole new vector. So you see how these 3 points created a vector that's like this. So when you do the cross product, you're gonna create a vector that's orthogonal to both of those vectors. So you're probably going to make a vector like this, depending on the way you cross it. Or you could have a vector like this. You see how that's orthogonal? That's orthogonal to this, and then that's orthogonal to this. Another word for orthogonal is perpendicular or normal to both of those vectors. And how do you create a cross product? How can you compute it? Well, it's a little different. What you do, you actually use a matrix. So if you want to dot both of them, right? You want to dot P to Q. This is the symbol. It's just like a multiplication, but it's not actually multiplication. It's very different. And then Q to R. And then what you do, you find the determinant of the matrix. So because we have three components, we can call this the I, J, and the K components. And then this will go in the other row, in the third row. So the PQ, so you're going to put the component 0, 4, 1, and then the QR, you're going to put its components, so -6, -4, then -6. And now you're ready to compute the dot product. The cross product. So what you do, the way I like to do it, I forget about this one first. And then what you do, multiply this two. So that's going to be -24 minus, you always do minus, and then you go here. Then you cross this two. Then that's going to be +4. Because -4 times 1 is -4, and this is a -1. So +4 times J. So the one you were not using, the column that you were not, the column that you were not using. And then minus, so it's plus, minus, plus, minus. And then you're going to do very similar, except you're going to forget about J and multiply this and this, which is just going to be 0. Multiply this and this, which is going to be -6, but there's a negative right here, -6, so +6. That's going to be J. And then this is going to be plus. So again, you're going to cover up the K. And then you're going to do 0 times -4, which is just 0. Then minus -6 times 4, which is -24. It's a positive, so it's a negative right here, so it's a -24K. So to simplify this, we're going to have -20I minus 6J plus 24K. So now you're saying that, so now you just created a whole new vector right here. A whole new vector. So let's see where the position is, if it maybe makes sense. So -20. Oh, look, and what we can do, we can actually divide everything by 2 to simplify it more. So sorry. So this is -10I minus 3J plus 12. Okay. So let's see. So this is going to be -10, so it's going to go all the way here. Then -3 all the way here. Then plus 12. So it's going to be like around this direction. So if I draw it, this is P, this is Q, and this is R. It's kind of going to point this way. And then that becomes your new dot product. This is going to be very important on the future discussion that we're going to have. So that's how you compute that dot product and a cross product. Next time we're going to see how to create planes, and we're going to talk about lines and do examples. Okay, thank you.